Okay, we're talking about the part for 5C now in the textbook. So first of all, key term, you will need to know this: mutually exclusive events. Mutually exclusive events are, let's reveal this one, events that cannot happen at the same time. So a good example would be rolling an odd number and rolling an even number when you roll some dice. Okay? If they are exclusive, then the chances of them both happening at the same time, A and B, well, that's zero, isn't it? Because, you could draw this sort of an event diagram. If you had odd, and then if you had even, they would be completely separate groups. There would be no intersection. Yeah, no intersection. Because you would have 1, 3, 5, 2, 4, 6, and we wouldn't have any other kind of numbers. Every number is an odd or an even number if we talk about integers. What's the probability of A or B? So, what's the probability of rolling an odd or an even? Well, it's 1, isn't it? Why is it 1? Because what you're doing is you're taking the probability that it's odd, that's a half, and you're taking the probability that it's even, that's a half, and then you're adding them together. So if you want to look at A or B when they're independent events, it's as simple as just adding them together. Let me give you another example. Rolling a 1 and rolling a 2 are also mutually exclusive, aren't they? There's no overlap between rolling a 1 and rolling a 2. Well, when we're talking about rolling dice, that's a 6, that's a 6th. So if I said to you, what's the probability of a 1 or a 2? Well, you would just add them together. Okay, so that's what that looks like in practice. So your Venn diagram would have no overlap between them. Yeah, that's mutually exclusive events. So mutually exclusive events, burn it into your memory a couple of times here. They cannot happen at the same time. They cannot happen at the same time. They cannot happen at the same time. Can you roll a 3 and an even number at the same time? No, they are mutually exclusive then. Can you roll a 1 and a square number at the same time? Well, what are the square numbers when you're rolling? You can get a 1 and you can get a 4. So, yes, they overlap. They can happen at the same time. What about a 1 and a prime number? Well, there's no overlap there. So, no. Again, this means mutually exclusive. Mutually exclusive. When they cannot happen at the same time, they are mutually exclusive. Okay, so I'd encourage you to have a look at the rest of those events and just think about them. Can they happen at the same time? Now, this is where it gets tricky. I'm about to talk about some other vocabulary. This is completely separate. It has no connection with what we're just talking about. Mutually exclusive. They are mutually exclusive if they cannot happen at the same time. Well, what are independent events? Independent events are quite separate to this. Independent events are events where one thing does not affect the probability of the other. Okay? And just to note one more time, it does not affect how the circles look on the Venn diagram. That's really, really important. If you need to pause the video and go back and look at mutually exclusive events and then rewatch this part on independent events, you need to do it. They are separate things. Okay? So this is when the probability of one thing does not affect the other. So, for example, the probability of me having noodles for dinner does not affect the probability of your favorite footballer scoring a penalty. As much as you might think it does, it doesn't affect it. Okay? If you thought that loads of things affected other things, I guess that would be quite a superstitious thing. That would be dependent events, because you are saying that one thing is influencing another. But we're talking now about independent events. So it means they do not influence, they do not affect each other. If they are independent, this is a key thing for your notes. This is going to come up a lot. If they are independent, then the probability of A and B happening, so the probability of them both happening, is just the first one multiplied by the second one. And you would have seen this before at GCSE. Okay? Don't think about this as a Venn diagram. Independent events, okay, will not be reflected on a Venn diagram. You will not see this on a Venn diagram. What we are just saying is that if you want to find, for example, the probability that I eat noodles the same day that Messi scores penalty, you take the probability that I will eat noodles, the probability that he will score a penalty, and you multiply them together. And that is it. Okay? If this doesn't work, so let's pretend, if this probability is maybe given to us, or we see it in a diagram, if this is 0. Let's say 0.2, but the probability that I eat noodles is 0.1, and the probability that somebody scores a penalty is 0.1, what you could do is you could say, well, 0.2 is not equal to 0.1 times 0.1, because that's 0.01. What would that mean? Well, that would mean that it is not independent. So many questions will center around showing something is or is not independent. If it is independent, then this thing here will work. If it's not, it won't work. You'll get a mismatch of your numbers. So let's give some examples. I pick one of the numbers 1, 2, 3, 4 at random. What's the probability I pick a multiple of 2? Well, I'm essentially saying what's the probability I pick an even number? It's a half. What's the probability I pick a multiple of 4? Well, that's 1 out of 4. These here are clearly not independent. Why are they not independent? Well, think about when you roll a multiple of 2 and when you roll a multiple of 4. They're not independent because if you're talking about a multiple of 4, a multiple of 4 is always a multiple of 2, isn't it? So this is not really independent. These things here are connected to each other. Okay? How can we show that they're not independent? Well, this is a good application of this. So what's the probability of getting a multiple of 2 and a multiple of 4 at the same time? Well, that would be 1 out of 4. So let's write that down. Let's write a 2 and... So write a multiple of 2 and 4. Well, that is 1 out of 4. If it's independent, this should be equal to the probability of a 2 multiplied by the probability of a 4. So let's see if it works. The probability of a multiple of 2 is 1/2. The probability of a multiple of 4 is 1/4. If you do a half times a quarter, you get an eighth, which is not equal to a quarter. So here we have dependent events. Okay, we have dependent events because it doesn't match up properly. Okay, therefore they are not independent. This is a very, very, very common exam question. Okay, it's quite common that you will have to pick the A and B piece from inside the overlap of a Venn diagram, and then you will have to multiply A and B together and show that it is or is not equal to what is in the diagram. That's a very common question. Okay, a couple more further examples here then. So events A and B are mutually exclusive. What's the probability of A or B? So just take a moment, go back to mutually exclusive events. How do you find A or? Well, we add them together, okay? We add them together. So we've got 0.6, yeah? We just add them together. What's the probability of A but not B? Well, go back to your Venn diagram. We're talking about the probability of A, but it also cannot be B. Well, that doesn't really make any sense. They are completely separate things. So it's just the same as finding the probability of A. Neither A nor B, well, that's 0.4. Sorry, that's not 0.4, that's 0.2. 0.2, that's 0.4. So there must be 0.4 outside, but within the diagram. So that's what we're talking about for the next part. Events A and B are independent. This is A, this is B. How do we find A and B? We multiply them together if they are independent. Okay, so a third times a fifth, 15th. The Venn diagram shows the number who watch 3 programs, A, B, and C. Find the probability that a student chosen at random watches B or C or both. Well, B, or C, or means shade more, or both. Well, I don't actually need to shade anything there because I've already shaded both, haven't I? But I mean, that's what both looks like. So that is 9, 19, so that seems to be 26 to me, okay? 26 over 30. Determine whether A and B are statistically independent. So this is a question about independent events. Notice the Venn diagram. There's nothing special going on with the Venn diagram. Kind of looks pretty regular for A and B. If they are independent, what does it mean? It means that probability of A times the probability of B should be equal to the probability of A and B. Can we get any of that from the diagram? Well, let's start with the A and B, because this is the piece that's normally in the diagram. A and B means the overlap. So that's 4 out of, I'm going to sort of cheat here a little bit, out of 30. Okay, so if I added all of these together, I should get 30. So if I find A and B now and multiply them together, do I get 4 over 30? That's what the question is. If I do, they are independent. If I don't, they're not independent. That's it. So A, what is inside A? It's 7 over 30. B, what's inside B? Inside B is the 4, the 5, and the 10. So it's 19 over 30. So if I multiply these together, do I get 4 over 30? That is the question. So I do a quick multiplication. Well, actually, we can just borrow the working out. If I do this, I get 133 over 900. Notice the denominator is different. So we just need to say then that this would not be equal to 4 over 30. In other words, it's not independent, it is dependent. So pause the video, have a quick go at these ones here, especially the third question is very, very good. Okay, so assuming you've done that, A and B are mutually exclusive. So A and B here should not overlap. C, though, C could overlap with A and could also overlap with B. A is 0.1, B is 0.6. Determine neither A nor B. Well, it's the thing outside of 0.1, but also 0.6. Must be 0.3. If you're not sure, go back into the video. We did discuss that one earlier. Determine if A and B are independent. So 4 out of 15 the same as 10 out of 15 times by 9 out of 15? That is essentially the question. It turns out no, it's not. Over here, handle things as you normally would. So this is X as the AND part. A is 0.3 plus X, B is 0.2 plus X. You can make it a quadratic and solve it, and you will find there are 2 values that would make this independent. Okay, so that takes us to the end of 5C.